In this video, we want to solve this logarithmic equation. And initially, it's important to notice that there are three terms altogether in this equation. We've got one term on the left, and we have two terms on the right. Two of these terms contain logarithms. So we want to first get the logarithms on the same side of the equation. So we're going to start, since we have this logarithm here that's being subtracted, we'll start by adding that logarithm to both sides. So we're basically bringing it over to the left-hand side of the equation, giving us log base 2 of x plus 5 plus log base 2 of x plus 7 is equal to 3. Once we have the logarithms on the same side of the equation, then we can take these two logarithms and condense them into one logarithm. Because these logs are being added to one another, when we condense them, we are going to multiply the arguments. And the arguments are x plus 5 and x plus 7. So condensing these will give us log base 2 of x plus 5 times x plus 7. We're multiplying those arguments, and that's equal to 3. Now, this equation right now, it just has one logarithm, so it is in log form. And to get it out of log form, we want to rewrite it in exponential form. So remember, to do that, you're always going to start with the base, and it'll be the base raised to the power that is on the other side of the equal sign. In this case, 2 to the third power is equal to the argument. So the exponential form is 2 to the third is equal to x plus 5 times x plus 7. Now, 2 to the third power, 2 times 2 times 2 is 8. And then we'll go ahead and distribute here. So we'll have x times x is x squared. Outside is 7x. Inside is 5x, so that will give us 12x. And then last is 35. Now, if you had wanted to multiply the x plus 5 times x plus 7 earlier in the problem, that would be completely fine. Now, my equation that I have at this point, it is no longer exponential or logarithmic, but this one is actually quadratic. Remember, it's a quadratic equation because of the degree 2. And we want to go ahead and set this quadratic equal to 0, so we'll subtract 8. So subtracting 8 from both sides, 35 minus 8 will give us a positive 27. And then we're going to go ahead and try to factor. Remember, if this quadratic does not factor, then we can always do the quadratic formula. So x times x is x squared. We need two numbers that multiply to give us 27, but add to give us positive 12. And it looks like 9 times 3 is 27, and 9 plus 3 is going to give us 12. So therefore, either the quantity x plus 9 is equal to 0, or x plus 3 is equal to 0, which means initially my solutions are x is equal to negative 9 and x is equal to negative 3. Now, I say initially because remember, on logarithmic equations, you have the possibility of extraneous solutions that do not work. And that's because the argument of a logarithm cannot equal 0, and the argument cannot be negative. So we do need to go back to the original problem and think about plugging in these two values, and we want to be sure that the argument will be a positive number. So for example, if I substitute in negative 9 for x, then this argument of x plus 5 becomes negative 9 plus 5, which would be negative 4. And that would give me log base 2 of negative 4, which is undefined. So that tells me that negative 9 is an extraneous solution. So we're going to go ahead and cross it out. You could mark it as extraneous if your instructor requires that. Then we'll do the same for negative 3. So plugging negative 3 into either of these logarithms, we have to make sure that it works in both. So if I plug negative 3 into this logarithm, the argument will be negative 3 plus 5, which is positive 2, so that works. And if I substitute negative 3 into the other logarithm, negative 3 plus 7 will be positive 4, and that works as well. So that tells me my only solution is x equals negative 3. And if you wanted to put that in curly brackets and write it as the solution set, you certainly could.